This conference will now be recorded.
So yesterday I learned confirm. So we have seen how to create environmental matrix from the data file. Okay, data file. In just working environment, how you get a file in the style 2. In style 2 or style 3, you will get a file. So based on that vertical mode, how to create your data matrix, that is environmental matrix, we will see. Okay, so I will open that file. What is the file name we have given? Rules 2. So this will be the sparse matrix style. So look at first 6 rows, sir. So here left side is state, second field is action, the third field is reward. So you can apply the header also. This CSV file you will have a header. The header will be like this. State action. So in this way the file format. Entire first 6 rows are talking about state number 0. State 0 to 0, 0 to 1, 0 to 2, 3, 4, 5 like that. Next 6 is about action. In this way we have 6 states. 0 to 5 means 6 states. 6 into 6, 36. Totally there should be 36 rows. So here rewards. Whenever there is no access, which is invalid action, -1. Okay. If there is a vacancy but no result, we have given 0. If it reaches goal state, 100. Okay. So how to create from this we will see. All the things are ready. Come to this Python. As usual, we are opening the file. Rules2.txt. We have first line header, we are separating it. Read line. So first record is right. So record pointer will be on the second line. Second line onwards, we need to read all the remaining rows. Okay. F dot read lines is the function. Print lines. Okay. We just check how many lines are there. Except header, there should be 36 lines. So perfectly it is done. So now how to prepare your matrix from this? Because yesterday data is cleanly in the rows and columns format. Directly have read the previous logic is okay for that. Now we need to change little logic. Of course, very simple logic. That if you take help of NumPy, the process will be more easy. So before getting into this one, in NumPy one technique I will show you. I'm taking one simple single dimension list. The values 10, 20, 30, 40, 50, 60, 70, 80, 90 I'm taking. Totally how many values are here? 9 values are here. I'm going to make it as a NumPy matrix, NumPy array. So NumPy is a module for linear algebra in Python. Because our entire machine learning, reinforcement learning is based on linear algebra mathematics now. That with multi-dimensional objects. That's why importing NumPy module. Setting one alias as NP. Here X is a normal Python list. Let's convert this into NumPy. Let's say A equals to NP.array of X. Just check what is the dimension of A. N dim. So it's a single dimension. What is the shape I want to check? The shape is giving you a tuple shape. If it is double dimension, row and column. If it is single dimension, only number of elements it will give. Observe here, there are 9 elements. After comma, nothing. That means you can understand that is a single dimension. I'm going to convert this into double dimension. I want to convert this into rows and columns format. A dot reshape. If anything is a NumPy array, that means NumPy object. To change its dimension, reshape is the function. Reshape of what dimension you want. That thing we need to give it. The input should be in the format of a tuple. Tuple or list. Anything it will accept. I want 3 rows, 3 columns. Now it is coming. So this technique, if you use this technique, your entire previous process made easy. Okay? All of you take up to these statements, we go for actual data. Online team, please take a note. I think already have taken data shape, right? Data, rules 2.5. Yeah. So online team, my voice is clear to you?
Sir. Yes, sir. Yes.
Okay. All of you completed? Yeah. Now let's work with our data. already we have read our records into lines. We have totally 36 data lines. How many states we have? As per our small game, how many states? Including goal state, totally 6. Actions, 6. In this example, both states, number of states and number of actions are equal. That means what you are expecting, 6 rows, 6 columns you are expecting. Okay. I am taking a for loop to read the values. SCNT is a variable for state count. ACNT is a variable for action count. Before for loop, all values are 0, initializing with 0. I am keeping the rewards as an empty list. I am starting reading data for line in lines. What is each line shape generally? Room 0, room 0, reward -1. This is what our basic shape. In the last of the line, backslash n is recorded. We need to eliminate that. And after that, we need to split. Same technique we applied in yesterday program also. Like that, words w equal to line dot strip. Line dot strip. Dot split. What is the delimiter? Comma delimiter. Default delimiter space in the Python. If you don't assign any delimiter, space is the delimiter default. But our data line is having comma separated. Okay. After that, at every iteration, I am giving one increment for the state count, one increment for the action count. Of course, you can use one variable, that is okay. But each element is what's up here. You have two commas. Two commas means that is split into three elements. Three elements in the list, but each element is a string. I don't want everything. I just want only the reward value. Reward is the last one. That's why I'm taking -1. In Python, you can apply negative index. In forward direction, 0 to up to n-1. Backwards on what you want to access means -1 means last one. -2 means last second one. Like that. But each value is a string converting into float. Because reward can be integer, reward can be float value. But state and action should be integer. Got it. The value, the reward value is converted into float. I want to append this to rewards. Rewards is an empty list previously. Rewards dot append. After completion of this loop, what happened? You just check it. Print number of states. SCN. Print number of actions. So here I am not verifying like how many states are there, how many actions are there, because both are equal here. But in so many cases, number of actions, number of states are not equal. At that time, you have to verify it. Understand? So the related code next we will see. In another example, I will take a disorder. But here there is one simplicity is there in the data. There is not that much of work in the data. Other here, room 0. After that, for the 6 rows, the state is room 0. But here, the data, the action data is in a sequence order. Room 0, room 1, room 2, room 3, room 4, room 5, like this. Luckily, everything is in order. But in lot many cases, your rules data is not in order. At that time, you have to do sorting. that to multi-sorting. The prime sorting based on state, secondary sorting based on action. That means subgrouping. So sub-sorting, multi-sorting you can say. So in latter techniques you will see how to sort your data file. So think that data everything is in clean order. That's why I am not writing any complex code over here. If data is not in order, that if there is a mismatch in number of states and actions, your code has to be little changed. Okay, those processes in the next examples we will see. So now here the number of actions. A, C. At the same time, I want to check all my rewards. Rewards are in the list rewards. So how many rewards you are expecting? 6 into 6. 36 rewards you are expecting. Print number of rewards. Len of rewards. Just check the output now. So here that is a wrong answer. 36 states. No, there are only 6 states. Here 6 column. Actually 6 actions. But loop is running for 36. Every iteration you are adding 1 column, which is a wrong manipulation. So we simply delete. Observe this. I'm keeping a dictionary, SCNT as a dictionary. Or else keep it as empty list. Keep it as empty list. SCNT dot append of W of 0. What is the meaning? First element. First element is about state, right? ACNT dot append of W of 1. Second element. After completion of for this loop, for the SCNT, I am applying a function called set. SET. What SET will do? Set is a function to eliminate duplicates. Understand? Similarly, here set eliminating duplicates. For the eliminated contents, you are applying len. Now run the same thing. Now number of states how many? 6. Number of actions 6. Number of rewards 6 into 6, which is 36. Understood? Come on, take up to now. Online team, please take this. You are not able to see font size, font bucket.
Yeah.
wants to make fast? Can I go to next? Okay. So our list of actions are in SCND. Sorry, list of states and list of actions are SCND and ACND. Suppose let's say NS, number of states. I'm keeping the same thing into a variable. Then now set of SCN. Number of actions. Then now set of ACN. Now your rewards are in rewards. That is a list. I'm converting that into numpy. Capital R, let's say small r, rewards equal np dot array of rewards. Previously normal list, now it is a numpy, which is a single dimension. Need to convert that into double dimension. Dot re input should be a tuple. How many number of rows you want? NS. How many number of actions you want? NA. Of course, both values are 6, 6. Even in another environment, if there are 100 states, 200 actions, this program will work out. Got it? Now I'm going to check my values. This is capital. So just check what is the shape of this arm. It should be 6 by 6. So actually our notation for the environmental matrix is what? E. It's not rule, just a standard. 6 rows, 6 columns. Now check the values. Print. These are the results. What is the meaning of first row, please? 0 to 0, no vacancy. 0 to 1, no vacancy. 0 to 2, no vacancy. 0 to 3, no. 0 to 4, vacancy is there, but no result. That's why the reward is 0. And also 0 to 5, no vacancy. But second one is 1, no, no, no. 1 to 3, vacancy, no result. 1 to 4, no vacancy. 1 to 5, directly vacancy is there. That's why if you don't take the help of NumPy, lot complicated code you have to write. So NumPy is making you your 50 lines of code into just 4 lines. Actual process is here only, in these 4 steps only. Before that, little data preparation, extracting of those rewards from your text file. Got it? So on that way, first you have to prepare environmental matrix. Generally, you get files in style 2. What I have seen in rules 2 file. Of course, in another case, in the style 3, like rules3.txt, on that style also you will get the file. So now we will see that how to convert the data type. Come on, take this, all of you. Now all of you understood this. Simply that reshape is there. Enough. First to convert your rewards into NumPy array. The NumPy array object dot reshape. Because you need matrix, double dimension. Completed? Now you tell me how to prepare your cube. What is the shape expected for cube? Same size as E. Remember, sir, environment matrix size, knowledge matrix size, both should be same. But initially, before trying all values, zeros. Come on, yesterday you have seen. Tell me the statement. NP dot zeros. You need shape, right? In the place of shape, directly give E dot shape. E dot shape is already 6 by 6. Now one matrix will be created with 6 by 6. All values are zeros. Print Q. Okay. Now you can start training. The training related code you need to write it. So in the coming classes, we will see like how to create your agent and how agent selects actions from a particular state, how to trigger the initial state, and how it receives the rewards. Based on the reward received, how Q learning equation will update the knowledge in the queue. So all these points we will be learning. Okay, step by step we will go. Come on, take the last two statements. We go to the next level. Now let's start working with the style 3. I'm taking that file now. This time my file name rules 3, but we need to change data here. Please modify this data. No, 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 yes, no. Whenever 100 means that is the meaning. Please give me 2 minutes. I will prepare this. Already. Everything ready? Now the header might be like this. State action. No, yes, these are the rewards. No. Let's say your own tag, your wish. Rules are door vacant or not. You can decide. Okay, that means what is the meaning? 0 to 0, you are not allowed. 0 to 1, not allowed. But 0 to 4, you are allowed. But no result. It's not a goal. Look at this point, sir. Room 1 to 5, you are allowed. At the same time, 5 is your goal state. Understood the point? I am saving this part. Now let's convert this into your reward matrix. That means environmental matrix. First of all, you have to fix for what kind of rule, what kind of reward you want to give. So here I am fixing same as previous. For no, -1. For all yes, 0. For all goals, 100. On that way, you have to first fix up. Now I am going to start working with this. All of you little concentrate here. Still the same file I'm taking, file object, let's say ins. Open file name, same path I have given, rules 3.txt. Your first line is header, file object ins dot read line. The first record will be that. You can check it now. Now record point is on the second, all the remaining data lines you have to read. Let's say D lines, where D lines for data lines. Ins dot read lines. Till end of the file, all the records will be read. Print D lines. There should be 36 as usual. 0. What 0? One minute. Once again I'm reading. Now you don't get it. All of you guess what happened? What the mistake happened here? First time you read it, what happened? When ins dot read line has read first time, all the data lines read, record pointer in the end of the file. Once again, if you run, there is no record at that moment. That's why empty record has. Mr. Abhilash, understood this? No. Now I am running this. Observe empty. Means what? Already record pointer is on end of the file. Once again, if you run, from the record pointer onwards, it tries to read the next lines. But there are no next lines. Got it? So I am repeating this first box. Now record pointer is on the second line. Now I get all the 36 records. Are you getting my point? To avoid this problem, simply don't worry. Keep this in a separate box. D lines equal to ins dot read lines. Now first time I am going to run it. Print line out D lines 36. Second time I am running the same thing. Still 36. Understood the point? Okay. Now as usual, same story. Already you have NS number of states. And also you have NA number of actions already in the previous code. Got it? Number of states is 6, number of actions 6. Now I need to concentrate only on the rules. We have only 3 options in the rules. What are those? No, yes, goal. First, reward smaller. I am creating a dictionary. If rule value is no, what is the reward you want to give? -1. Observe the symbol here, curly brackets. That is a symbol of dictionary. Dictionary means collection of key value pairs. Collection of key value pairs. If it is yes, 0 we are giving value. If it is goal, 100 value we are giving. Actually, this information will also be available in a separate file. Understand the points? Because here rule states are only 3. In some other things, rule states might be 100. At the time, what is each rule state? And what is the reward value for that? Those will be given in a separate file again. Understand the point? At the time you have to read the data from the multiple files. So in later complex environments we will deal with that. Now this is a dictionary now. All rules I am going to extract into this one empty list. I am going to perform a loop for line in D lines. As usual I am splitting W equal to line dot. Better practice always strip. And also this is text data. Convert into lower. Because some characters into capital letter like uppercase, some into lowercase, such kind of problem you may get. Dot delimiter as usual. Now 2 commas so that you will get 3 fields, 3 elements in the list. But your required answer is on third one. That's why rules dot of it. W of minus 1. That is already a string. No, yes, goal, these are the possible values. Understood this all of you? But if I append this, what will be added? No, no, yes, goal, such kind of values are added. But I don't want them. I want numbers. These numbers are already in R. If I pass that label into the dictionary, I will get a value. Suppose first value is no, sir. If I pass no as a key to the dictionary, if I pass no, I will get -1. If I pass yes, I will get 0. If I pass goal, 100. Think that. For the first record, room 0 to room 0, what is the rule state? No. If no is passed, what I will get? -1. -1 is appended to rules. Think that the second one is yes. If yes is passed, 0 will be appended. The third one is goal. If goal is passed, you will get 100. After completion of this loop, all values are ready in numeric formats. Very simple, right? That's why in entire data science and artificial intelligence, Python is superhero. And same thing, try to do it in your Java, sir. Already Java developers are here. You need to spend till afternoon to write this code. But Python is just finishing this work in 4 lines. Why Python great means because of its simplicity, and also very rich in library. Even complex functionalities with less code you can develop it. Okay. Come on, sir. Let's forget about Python. Now rules is ready. Is a normal list. As usual, convert that into matrix. Let's say RW rewards np dot. Okay. Environmental matrix em np dot array of rules. Now it is a single dimension dot reshape of number of states comma number of actions. At the same time, I want to define my key matrix, knowledge matrix, np dot initially all values zeros of em dot print em, same as previous, right? On that way, mostly in style 2 and style 3 will get data about your environmental groups. You have to prepare in such a way. Queue already created, but here with the em, how to create your queue house. Print queue em, knowledge matrix, like this. Understood all of you, both the techniques. Come on, take this. In the comment, take schema. Here schema means data structure, that is structure of your data. First field is state, next is action, next is room. The sample data is like this: room 0 to room 0. Vacancy? No. Already have taken yesterday the data sample. First box completed. Second. All of you understand this line, sir. Rules dot append of R of W of minus 1. So first we have a dictionary. To the dictionary you are passing key, you will get value. Here no as goal or keys. Minus 1, 0, 100 are values. Dictionary means is a collection of key and value pairs. Okay. Then last part as usual. Convert into numpy array and change the shape of it. A small point, sir. Hello, Mr. Naveen. Listen me. This is a reinforcement learning. Before you training the student, who is your student here? Agent. That means learner is agent. Learning from environment and updating the kit. That means knowledge. That's why if the problem is reinforcement learning problem, your data preparation should be like this. If problem is machine learning supervised learning, again data preparation is different. Again in the deep learning, your data preparation is different. So everything, the data preparation is a major key part here. Whatever model or agent is expecting data on such a way how to prepare your data. At the same time in machine learning or deep learning, different models are there. Model to model, again different varieties of data expectation is there. How your model is expecting, how your agent is expecting, on such a way data preparation. Actually nowadays no need to worry about the data science and a lot of AI models. But here at the time of teaching, we are writing without libraries the code. But mostly in industry, they work with libraries. Any agent model training or any model training of machine learning with the help of libraries, just a matter of 3 to 4 steps. Just a matter of 3 to 4 steps. But your code looks 100 lines means 70 to 80 lines will be killed by data preparation. Once data prepared, remaining part is very easy. A lot of libraries are there. But what exactly happening, what is the background of that library, what is the mathematics behind that, we will learn. After that, we will see the libraries also. Got it? But get good grip over this data preparation. Okay, data cleansing is important. Once data got cleaned, data preparation is done. After that only, you will be selecting models and then training the models, evaluating the models. That means testing the accuracy of the models. Finally deploy. But majority of the, suppose one project is going to take some 30 days of time means 20 days of time will be killed by the first pre-processing only, like cleaning and preparations. Okay? Yeah. Okay, sir, all of you. Let's see in tomorrow class. So today the statistics session I am not going to take. Yashoda has a question here. What is NumPy? Numerical Python is a library for linear algebra. All matrix related computations and linear algebra related all mathematics are predefined in the NumPy. But it works with a single dimensional object, multi-dimensional objects. Okay. Yashoda, in my YouTube channel, you
Thank
have
you.
NumPy. Please go through that.
Sure, sir. Thank you.